In this question, we're asked to determine the difference of order of magnitude of launching the space shuttle and a diesel freight train at high speed. Looking at the table above, notice how the sound pressure for launching the space shuttle is given as 2 billion micropascals, and the sound pressure for a diesel freight train at high speed is given as 200,000 micropascals. Now let's review how to determine the difference in order of magnitude. Given two quantities A and B, we use the following formula to determine how many orders of magnitude A is greater than B. The difference in order of magnitude is equal to the common log of A divided by B. To understand the meaning of this, if one quantity is 10 times or 10 to the first times larger than another quantity, it is one order of magnitude larger. If one quantity is 100 times or 10 to the second times larger than another, it is 2 orders of magnitude larger. So notice how the order of magnitude is equal to the exponent on 10, which is the reason why the difference in order of magnitude is equal to a common log. Remember, logarithms are exponents. So now going back to our example, let's write the sound pressure in scientific notation. So 2 billion would be equal to 2 times 10 raised to the power of, to form the number 2 from 2 billion, we have to move the decimal point left 9 places, so 2 billion is equal to 2 times 10 to the ninth. And now for 200,000 in scientific notation, we'd have 2 times 10 raised to the power of, to form 2, we move the decimal point to the left 5 places, so 200,000 is equal to 2 times 10 to the fifth. And now we'll determine the difference in order of magnitude, which is equal to the common log of the sound pressure of the space shuttle launch, which is 2 times 10 to the ninth, divided by the sound pressure for the diesel freight train, which is 2 times 10 to the fifth. Now we could just type this in the calculator, but let's go ahead and simplify this by hand. 2 divided by 2 simplifies to 1, and then we have 10 to the ninth divided by 10 to the fifth. Because the bases are the same, and we're dividing, we subtract the exponents. So this simplifies to the common log of 10 to the power of 9 minus 5, which equals 4. So this 10 to the fourth tells us that the sound pressure for launching the space shuttle is 10 to the fourth, or 10,000 times stronger than the sound pressure of a diesel freight train at high speed. And the value of this common log tells us a difference in the order of magnitude. So if we let x equal the difference in the order of magnitude, we'd have the log equation x equals the common log of 10 to the fourth. Now if we recognize here x is going to be 4, that gives us a difference in order of magnitude, but if we don't, we would write this log equation as an exponential equation. And because this is common log, we know this is log base 10, and so to write the equivalent exponential equation, notice how the base is 10, the exponent would be x, and this would be equal to the number 10 to the fourth. So the equivalent exponential equation, again, would be 10 to the x must equal 10 to the fourth. And notice how here, because these are equal and the bases are the same, the exponents must be equal, and therefore x equals 4, which tells us the noise of launching the space shuttle is 4 orders of magnitude greater than the noise of a diesel freight train. Now we did solve this by hand, but I do want to show how we could have evaluated this using the calculator. We could have just entered the common log of 2 billion divided by 200,000 close parenthesis and enter, which also gives us the difference in magnitude of 4. I hope you found this helpful.